Hi everybody, today you are going to work on karyotypes. A karyotype is if you look right here in the vocabulary, is the number and appearance of chromosomes in the nucleus. It is a map of the chromosomes in the genome. So it is where technically scientists will be able to separate out the chromosomes in the nucleus, and they create a little map where each chromosome is paired with its homologous pair, and they are organized by the number that are pretty much universally agreed upon. And just one more word, genome. A genome is the complete set of genetic material in an organism. So you'll hear if you start reading much, things about the human genome. That means all of our genetic material, all 46 chromosomes. So information we should already know that I have talked about, humans have 46 chromosomes or 23 pairs. So we have one copy from each parent. If you look at this karyotype, we should be able to look at it and see there's 18 plus this weird X and Y. So there's 19 total pairs, 38 chromosomes. So this is definitely not a person. This is not a human. This is some sort of other organism. And we will be today looking at a dog and a mouse karyotype. So the other part of this learning target is I can use a karyotype to identify the sex of an organism and the difference between species. So right here, you'll see that humans and most organisms inherit sex through these two chromosomes called the X and the Y chromosome. Males will have an X and a Y chromosome. They inherit an X from their mother and Y from their father. Whereas females tend to inherit, or they do inherit, two X chromosomes, one from each parent, one from their mother, one from their father. There are other genotypes that people sometimes inherit, such as XXY or XXX. This alters their development in some way. We're not going to talk about it very much. I think one of these might be on the activity you're doing here in a little bit. Just to be very clear, this happens because during meiosis 1, homologous pairs line up in metaphase and then they're pulled apart in anaphase 1. So if there is a mistake in how they are pulled apart in anaphase 1, so for example, if both X chromosomes go one direction or the X and the Y, they don't separate, then you will have some instances, very few, where there will be 3 copies of a chromosome instead of 2. All right, so the first genotype, we've got 23 sets, which means it's probably a person. And you'll see that the X and the Y chromosomes are down at the bottom, and they tend to be labeled X and Y. One big thing, so you're going to look at this, you're going to determine whether this is a person is female or male. There are 2 X chromosomes, just as a hint. Down here, you'll see the Y chromosome looks very different than the X chromosome, so you shouldn't be confused by it. The Y chromosome is very small compared to the X chromosome. So this person is clearly X and Y. So that would be the real key in knowing the difference between the X and the Y chromosome is the size. So this person has 23 sets of chromosomes, so it's definitely a person. We move here as a dog. So the dog has 38 plus the sex chromosomes, which are 39 total sets of chromosomes. You'll see here that Y chromosome is very small compared to the X. And here's the mouse. And the mouse has 20 sets of chromosomes. So you'll see here the Y is very small compared to the X as well. So after you finish kind of answering these questions that I just went over briefly, you are going to move on, and there's an activity called karyotyping activity. You'll click on it. I want to go over this today just because in the past students have had a little bit of difficulty understanding how to use this website. So on this website, the first thing you want to do is just quickly read about patient A, B, and C. And you want to start with patient A. So click. You're going to match this chromosome over here with the missing spot. And chromosomes they're matched based on relative size, and they have the same information on them. So you'll see even the banding patterns, which you can see bands, darker and lighter bands, are similar. In some cases on a karyotype, it'll look like they're a different shape. They're really not. It's just the image that was snapped at that moment. It was bent in some way or from a slightly different angle. So you'll take these and you'll compare them. And it should be fairly obvious which one it matches with. So this one matches with 2. Now, what my students try to do in the past is drag and drop. So we'll put here, and it doesn't drag. It doesn't stick. So that is not how you do this. You're going to click on the number you think it belongs with. Here we are. And then it moves you on to the next one. Here's a very small one. So you can move it. This one's fairly obvious. I'm going to choose the wrong answer on purpose here just so you'll know what happens. So here, I'm going to say, oh, it belongs with 12. It will tell you it's wrong, and then you will try again. All right, and then you can just quick click through. This actually probably once you get started doesn't take long. Now you're like, hey, this is the complete set. There's one more chromosome here. So don't forget that. So this is 21. So you have interpreting the karyotype, making a diagnosis, and then they have an image of this karyotype again down here. All right, so you want to make sure you're always scroll down. So going through the questions, I'll just kind of go through this at first with you guys. What is the sex of patient A? So you do need to go back to the karyotyping activity and say, oh, two big ones. So the sex is XX. So it is a female. Okay, patient A has 3 copies of a chromosome instead of 2. Which chromosome has 3 copies? So we're going to look here. It's chromosome 21. So you'll type that in. All right, read the section called Making a Diagnosis. What genetic syndrome does this indicate the fetus has? So if we go to up again, so history, making the diagnosis, you're going to read this. They will probably tell you an answer here. The next step is to either diagnose or rule out a chromosomal abnormality. In a patient with a normal number of chromosomes, each pair will have only 2 chromosomes. Having an extra or missing chromosome usually renders the fetus inviable. That means it's not able to survive. In cases where the fetus makes it to term, that means the whole 40 weeks and that it's born at a normal time, there are unique clinical features depending on which chromosome is affected. So we're going to look here. Patient problems are due to something other than abnormal number of chromosomes, so a normal number of chromosomes. Klinefelter syndrome, one or more extra set of chromosomes, so XXY of the sex chromosomes. Down syndrome, most of you have probably heard of this. This is also called trisomy 21, extra chromosome 21. Ding, ding, ding. There's also trisomy 13. It's an extra chromosome 13. So we'll come back over here. This fetus has Down's syndrome or trisomy 21. So you can go back, I'm done with patient A, and come down here, and you can click patient B, and you'll continue in the same way. All right, so good luck with this. If you have questions, reach out. This video should give you most of the information that I think you'll have problems with. So have a great end and great day.